Good afternoon, everyone. Dear Ben, dear project partners, and all participants. Welcome to our fourth webinar for the Erasmus Plus project 3D STEAM with the title Accelerating STEAM-related Knowledge and Skills via 3D Modeling and 3D Printing. Our speaker today is Ben Haas, a researcher and practitioner in special needs education based in Luxembourg, holding a PhD in STEM education from Johannes Kepler University in Austria. His research expertise spans STEAM education, remote and outdoor learning, and the integration of technology into educational practices. With a deep commitment to educational equity, he focuses on innovative approaches that leverage interdisciplinary learning and technology to support diverse learners. His work aims to transfer how we engage students, particularly those with special needs, by fostering inclusive, accessible, and dynamic learning environments that prepare them for success in an increasingly complex world. Let's welcome Ben with his presentation entitled Opening STEM for All, Outdoor and Tech-Enhanced Pathways to Inclusion.
Thank you, Yves, for the presentation. Welcome all. I'm happy to join you today and speak a little bit about inclusive education from Luxembourg, but also about the research we did on the theme about STEM education for all, so meaning for every child with or without special needs, and the focus on outdoor technology and aids pathways to inclusion. Many of the researches have been done over the last years in schools in Luxembourg, in the time of Corona and outside. We asked a lot about students working from home, students and their parents. We work with students from having learning difficulties or special needs in learning, special needs in autism. And we published several papers with Yves and other partners and colleagues from Linz and over the world through the last years. So today I want to just to talk about these subjects, and I will still start right away. As you see on the first slide, is something we came up, I think, at the end of the PhD somehow. This image about how important it is to connect all the learning somehow to the real world. And so I started with that. I started with something we found out at the end, that every learning, however, turns around how to connect to real world to give a meaningful and sensible learning. And out of this place or this result,
Ben, we can't hear you. I think you lost your sound somewhere.
Okay, and now you hear me? No?
Now we hear you again, yes.
Okay, this
I
must
think
be problem with the PowerPoint then.
yeah, I
But you
guess
can
we
see
lost
this.
you. We lost you at the end of the explanation of the first slide when you said at the end of the PhD you came up with this graph
Okay,
and so on. So maybe
but
step in again on this slide where you are now.
okay, so we always focused on thinking how can we support students, regardless of their ability, regardless of their background, their language, if they're boys or girls, if they live in the north, the south of the country, wherever they come, and this included as well as students with special needs. So it's always our design. We thought about the learning activities was more than just about the regular students, but was about every student. And that's why we came up more and more with the idea that it is also a good way for students with special needs, with different special needs, which we will later on explain more. And then the second point where we said, okay, in Luxembourg you have a huge system of inclusive education, which was built over the last years quite heavily. We have a lot of support system. We have very, very high supports for the students. And at the same time, it was a little bit time to say, okay, how just not changing the support system, we should step to the next level of how we could teach and how we could learn, and maybe we should change didactics more in a more innovative way. Then what we found out through our research is also that STEAM could be a way to make learning and inclusion easier. As you will see later on, that for some tasks, depending on your learning background or your abilities, you can solve different paths, and it's by rejoining these different talents that we have tasks which became more inclusive, because we don't ask all the students to do the same thing at the same time, but they just can put in their effort, their strengths in and do the task. STEAM also has the advantage to propose different ways to engage in learning. So to connect to real-world problem, arts, connect both ways, and so to create to engage different learners and including students with disabilities. And then we have Luxembourg studies showed a lot about STEAM tasks that boost motivation. So also students where we have a lack of motivation to go to school or difficulty to concentrate on classical learning activities, which found new motivation, higher motivation, and could again learn more efficiently. I wanted to do a small but important description of our system, because nonetheless we have a quite developed support system. We have a very high number of persons who work in this support system at different levels. So as you may see, you have we have regional schools, we have secondary schools, even in schools we have specialized teachers who can work with the students directly without having any decision of any commission or any need, so they can step in from day one. We recently added assistants, so persons who can assist during tasks, also for students who are, for example, they were in a wheelchair and could not go outside with the class or go to the swimming, or having special ways to dietary. So we have really, even at the same we have at secondary schools, so you can quite fast act and support students with disabilities when they are in school. Then we got a second layer where again we have resources where we could support students, schools for the tasks. And then we get, at the end, a national level where we have 8 specialized competency centers from language, hearing, autism, sight, learning, socio-emotional, motricity, and high potential. So for what is different in Luxembourg compared to other countries, we include as special needs the high potential. So this is also something we are looking for. And then we have a transition agency which helps the students get to work and so on. Different commissions who can also support the students with decision that they have to do less or more in different times, different places. Yes, so the focus is mainly that we do this, students stay in class, in schools as much as possible. We have still some students, but it's less than 1% of the students who go to special schools, but mainly they are, 99% are in the mainstream schools with different supports and adaptation. One first thing and one important thing is that the teacher, with help of specialized teachers, also can adapt his teaching. So knowing with different way of teaching, students can easier stay in class and learn. So that's something I said, classroom adaptation. Class teacher, when he can adapt it, he can also adjust learning and assessment conditions. We have, even for the students, workshops outside school. One example is makerspace. We have a lot of makerspaces with STEAM education also, where students can different tasks they did in the morning in class, but they retry it in a different way in the afternoon with specialized people. We have special support in class, and we can also ask students to go to another class for some parts of the day. And then we have this high situation for really students who have a huge need in special needs. We have special diagnosis, we have consultations, special learning work groups. We have, again, for example, for our high potential center is working on a STEAM lab, as they found out that with these tasks, those students actually can evolve faster and also work on different skills. So they have less the need of working on scholar matters, but more maybe on social matters, interactions, and working with different partners, so they can do that. They also these specialized centers can send people to the schools to support students, and we also have classes for students, for example, with a strong need in spectrum of autism or in cognitive development or whatever, which can go to these schools. But that, again, that's a number which is quite low, mostly under 1%. So what we see is also which is at the base of everything, is to create a learning environment. It's just not a task, it's just about to create a place where this task could happen. Looking from a special needs view, you have different points where you have to consider your task, your environment. So the thing is about how will my social interaction be within the task or around the task? Which cultural contextual context is given in my classroom, in my school, in my setting? How do I interact during the task or after the task with the students, with the group? The physical environment is very important, so that the student can actually has not to just sit in his bench, but he also can stand up or use different tools. We have different ways where they can interact. That's something we always say. So we talk about this universal design for learning. So providing multiple means of engagement, representation, and expression. This is one key principle I said for these learning tasks. We also look at adapting teaching strategies to meet diverse needs. equity over equality, so giving each student the support they need rather than treating everyone the same, and the less restrictive environment, ensuring students learn in the most inclusive setting possible, and the collaborative approach, working with teachers, specialists, parents, and students themselves. So this means also when a teacher does an adaptation for mathematics or STEAM tasks, he also can ask specialized and to create this setting, thinking about all the other elements. So we encourage teachers as well, not just to be alone and to try, but if I want to try, I can ask some experts from different ways. I have 3 quotes I always loved. So the environment itself will teach the child if we create the right conditions of learning. That's something we experience, which we will see in our tasks. So if your environment is rich enough, we have quite a lot of learning. The quality of learning environment is determined not by the walls of the classroom, but the engagement of the learners within it. So that's the second thing. I don't need to put a 3D printer and whatever in my class and it will work. No, I have to ensure there is an engagement, and I have to ensure there's an accessibility to the tool and an understanding of the tool. And so there's quite of work I have to do. It's just not putting the environment. So a learning environment refers to physical, psychological, social conditions in which learning can take place, includes all the factors that influence a learner's ability to acquire knowledge, develop skills, and engage in meaningful learning experience. So that's something through our research, and now I will go to the STEAM research, which we had always in mind. So we thought about, okay, what's the environment? Which material do you have? How can we make it accessible? What will the learner do who is maybe not so strong in mathematics, but very creative in other ways? What will we do with the movement? Is it accessible for everybody? And does it give sense? Every task we thought about, is it meaningful for the student? Some findings, examples from Luxembourg is, I would start with maybe something from the beginning, where we worked with students in the mathematical learning disabilities. So students which, it's quite a big range. We always, mathematical learners can be from just not reading numbers, but not understanding. So, but still students have some skills in mathematics. So what we did, we tried to find out which skills do they have and for which skills they would need support. And you see on the screen, we used a software, a CAD software, no, not a CAD software. And we used GeoGebra in this case, and augmented reality, where we said, okay, because these are tasks which you can find in school books. You have a cube, and you have to find how many small cubes you need to put in to have the full cube. But it's in a book. So, and then with this system, we tried, okay, let's go the next step, and we just trade the AR and we try to move it. So that's one task we tried to do. And then on the other hand, we took the same vision AR, but also we printed with a 3D printer these I don't know how areas, and students worked alone. So we trained with them these tasks. There were 2, and we talked with the teacher, so we adapted the learning, and they could use this tool during their learning, testing, and so on. So we had, the first thing we found out, they had a quite high increase in motivation. So they felt less not competent in mathematics, so they were quite fast to say, okay, I can do it with help. And we saw the benefits for the teachers. The teachers as well, very skeptical at the beginning, then again said, wow, it works. And it had a quite nice side effect, because with that tool, they started to explain mathematics to others again. And it was for other students as well. So using technology, we could help these students follow regular math classes, but in a different way. We changed the task. Instead of just a student having a book and a pen, we gave him an iPad, an AR view, and we printed out the parts. And so we make it more user-friendly and accessible. So higher motivation, lower frustration. We met the needs from the student, participate in class, develop new strategies, and it was the first step of this 3D modeling and manipulatives to represent maths visually. Again, we had different outputs, so different strategies, different way to enter to the task. The second research we did was we tried with students to engage in different way. So they use modelizations, again with the task to rebuild. So we wanted to connect. Some students had still say, okay, this is a classical task. It's not, I'm not motivated. How and or abstract problem solution. So we try to rebuild objects and with mathematics from outside. You see this little barn, and you have this paper, we say paper plane, and later on we printed it in the 3D printer. This is something we thought about this model from the real world mathematical modeling is, so what if we have a problem and a problem situation, and we wanted to try out to solve the problem. So instead of doing this task in school on paper, we went outside. We said, okay, let's rebuild it. Let's create a model, print it out, see it works. You see, and these modelations went back and forth with mathematical contents. So the teacher always was there and say, okay, did you thought about this? This. And at some point, students said, okay, I know this. I did not thought about using this mathematics for solving this problem. So they did not connect, which was quite interesting effect. And then this iterative process over again. On the screen, you see as another project we did as well during in 6th grade was to rebuild an egg cup. It was this task. You have to build an egg cup where you can put an egg on it. So you have to do this design thinking and to try out with an egg, without an egg, using different tools to measure or to try out. So it was this connection to this real world, real tasks with mathematical knowledge and leaving some space for creativity. What was very interesting is also we did it in group work. So you can imagine you have 3 to 4 students. One student is quite good in mathematics, scholar mathematics. He just says, okay, that's the size of an egg. We had to think about that. Then we have one student who is quite creative. We say, oh, maybe you could use this form or try it out. A third one is quite good at manipulating an iPad. We have then 3 to 4 students which have different backgrounds. In school, one is counted to be the best in class, the other one is the worst in class, but they still work on one project together and try to solve it. Students with learning difficulties, students with speech difficulties could actually work as well in these tasks. And over time, you see also that the idea of working in an inclusive way from the students is growing more and more. So afterwards, these students will become also these people where we don't see these barriers of working together, depending on if I have a special need or not. So again, increase of motivation. We connected school subjects to real world, better understanding. We started with very low tasks to up to complex tasks. We saw teaching with STEM education in an inclusive way. We saw that there are creation of barriers between students due to the task. So I don't work alone, but I can work on it. And maybe I see talents from the other students I did not see before. And we have a high participation. At some point we said, okay, let's just so I think it was a course we did online, or maybe I did from the MIT. It was called the iterative design process. It was about how in history you will design a pen. It was quite interesting because you do something, you try it out, you see it's not working. And maybe normally in class, you do something, it's not working, you get a bad grade, and it's done. But here you just say, I'm doing something, it does not work. I see what's not working. Okay, I go back to beginning and then try to correct myself. Is it working now? And again, something this in iterative design process. So you design something, you test it, refine it, you evaluate, design, so over and over. And we took students in groups, and we just said at the beginning, you have to design something using the 3D printer. So it has to be an object you can use, and you have to go on with it. So students were in a group. They made up an idea what they wanted to do, and they had to pitch at each session. So talk about what they were doing and telling what they were doing, and in front of the others, and discussing their designs and their objects. Again, then you have groups, you have students maybe who have maybe in the spectrum of autism who are not very keen to speak or act, but maybe they had someone in the team who understand them. They could put their input. So one is strong in speaking, and I don't effort the other one to speak. It's a teamwork. It's like, this is something different. Later on at work, you won't have to talk every time. There you have a team and somebody will present because he likes to present. And the other one is maybe very strong in research or very solid. So this idea made it also very accessible. Here you see some examples. So we have an elevator for a Lego figure, which was tried. But we had also a group who wanted to design a car. So they designed a car in the CAD software. They printed it out, but the car did not roll because they designed it in one piece, the car and the wheels. So again, they thought about it, restructured, then they built a car. They built the wheels separately, they connected the wheels and so on. So these projects took a half year to go through. The learning environment was giving there because they worked actively. We had a long period, and we got to in the deep understanding of physics, of concepts, and we did not lose something. At the same time, we did these team activities we thought about presentations, talking in front of people, describing what we did. Why does it not work? So changing the way we think and we learn, supporting each other. So this was quite interesting. I think at the last research we did was finally we went outdoor. So we said, okay, now we're still in school setting, even if we design, now would be the time to go outside. So we tried to do a task outside. And as you see, we used different tools again. We used GeoGebra to solve some tasks. We worked a lot with MathCityMap. So we created trails. So you go outside with your students and you do a math trail. So you move yourself to a place and then you have a task. You have to solve this task, maybe calculate something, measure something, using different tools, recreate something, collect something, build something. And then you do these trails in groups, you think about it, talk about it, and at the same time you recreate this task as well. We were in movement, so even students which have low concentration could easily be in that task. They could be there, they could be moving, so they don't have to be sitting in the classroom. We have interaction with the environment, and we have to use the technology to realize a lot of peer actions, high accessibility, and at the same time we went back to the classroom and we brought what we learned outside again into the classroom, and concepts of learning would be much easier to understand. So that was somehow where we stopped. Somehow, so we're still adapting trainings for teachers. With Eve, together we did these math trails and this 3D printing as well in the teacher training, because we thought if we want the idea was if you want a teacher to be more inclusive and more innovative, he has to feel it himself, because we reproduce a lot what we learn in school. So we let with the teachers, trainees at universities, so they built their own math trails. They did their own design thinking process. They thought about how to teach it, and they did it as well. So it was very important. It's something which we think is very important overall. When I define a task, how do I get teachers to use more STEAM like in this process? So I have to engage them, and maybe in trainings to experience themselves how good does it feel to do it. And they all had high motivation. They all were passionate about their work. I remember the day where they presented their designs finally. Somebody did a football table, some did a windmill, all was working. The designers were very proud of working that way, and they could relate to arts, mathematics, physical movements. They explained, so they had to do research. Think about the windmill. They thought about how does a windmill work. So even that showed that there's still some more opportunities. And again, here we had students who do not like mathematics, or teachers who teach us, we will be teaching mathematics, but we don't like mathematics. After this situation, they were much more likely to like mathematics, because they said, I never thought mathematics could be that. So, and that's something which still has to go on. I think another part is to create in schools places where this can happen. So adapt the environment, make 3D printing, having places where to be creative in mathematics for the schools, and also create a place where teachers can share these experiences. Because sometimes it's not so easy. You just think, are you doing your stuff or not? So I think that's quite important. And that was my short presentation. Thank you very much.
Thank you very much, Ben, for your insight of what is running in Luxembourg, with a special focus on inclusive education. I think that's a new point we didn't touch in this webinar series so far. And it's an interesting point to show that you can do all these 3D modeling things as well with these children, which might be encouraging others to step onto that path and to make more innovative teaching at the end. So far, I see no questions in the chat of YouTube, but there's one question from a project partner, Joseph.
Okay, I was. Do you hear me?
Yes.
Yeah.
Okay, so I was quite surprised by the fact that there are teachers of mathematics who don't like teaching mathematics. Okay, so tell me a bit more about that and the ways how you, I would say, move that to be more positive.
So I think we have to in fundamental schools you are a generalist. So you teach at the end you teach mathematics, German, French, history, geography, and some teachers are more likely to maybe like maybe more teaching a language, or maybe more sports and so on. But you have to teach every subject, and some teacher trainings are not very I don't know at ease in mathematics, so they fear. That's something we also see with students. Maybe they are quite good in mathematics, but they learn somehow that I am not good in mathematics. So, and they don't like it because they know I get that feeling I'm not good enough in that subject. So that's something we always try. We try to do to change the task and the way you experience. If you experience your mathematics learning in a good way, you can change the view on you have, because they did some good creations. They could have good results. And then that way, they experience that they are good enough. They get a positive feeling. So, and this changed quite a lot with this approach. That's something we have to do. We have to make them feel that it is good.
Okay, sounds good.
So it's not the classical mathematics professor. It's just because they have to be generous. So that's part of the job.
Yeah, so it's a reasonable way, I think. So thank you for explanation.
Okay, thank you.
Are there any further questions from project partners? Because I can't see any questions on YouTube. No, then I think we should end our stream here. Thank you very much again to the external audience, and see you back again in a month.
Okay. Have a nice day.
Thank you. Thank you.